reaction force calculation. In this particular scenario, we're trying to find out how much it is carried by each of these wheels. It is very important to know that piece of information. For example, let's say for this touring motorcycle, we want to have a 50% weight in the front wheel, 50% in the back wheel. So how do we distribute these different engine, chassis, and passenger, and some kind of recommendation for, is too much load for this as a passenger or rider. So things like that, it is very important to know how much it is coming at the front and the rear. Now the first step in solving any mechanics problem is to draw the free body diagram. Now this motorcycle is standing on the ground right here, so with the ground support. So free body is you take the ground support away. So then once you take the ground support away, you are basically knotting. So this wheel is start to fall down due to the gravity. So you have to apply that, balance that by the reaction at the front wheel. Now here in the rear wheel, same thing. When you take the support of this rear wheel, it will start to fall down. So you have to balance that by using a upward direction force. So that is the rear wheel, where this is the front wheel reaction. Now here is one thing, because it's a roller surface, as we have explained before, there will be only vertical reaction from the ground. For any smooth surface or roller, you only have vertical reaction surface. So we draw the free body, we get all the forces done, we have done the reaction forces. Now what you have to do to find out the forces, you just have to take moments in a way so that you can cancel most of the unknown is possible. Here in this case you only have two. You can take moments with respect to, for example, rear wheel. That will actually cancel that rear wheel force, because that will not cause the rear wheel. If you take moments with respect to the rear wheel force or the load carrying by the rear wheel passing through that moment, so that point, so you're not going to cause any moment. So the only thing will cause moment is this front wheel load. So you only have just one variable. So very easy. So you can do counterclockwise moment, positive, all moments sum to zero with respect to point A. So if we calculate that, so you got four different forces. This 250-pound passenger will do a clockwise moment. So you're taking moments with respect to A, so it's gonna do a clockwise moment like this. All of these forces with respect to A will do a clockwise moment. So they are all negative. So you can do, so then we can write 250 pounds times the distance from the rear wheel. We are taking moments with respect to the rear wheel. So if you subtract all of these numbers from the 64-inch wheelbase, that will give you the distance from the rear wheel of that passenger load, which is 7 inches I found. So 7 inches, and that is minus, and then minus for 350 pounds, and that is 7 inches plus 15. So that's going to be 22 inches I calculated, minus that 450 pounds chassis weight, and that is another 8 inches away. So that's going to be 38, or 22 plus 8, so that's 30 inches away, plus minus the 400-pound engine weight. That will also cause a negative moment, and that 400 pounds is another 9 inches away. So the total 39 inches away from the rear wheel. And then that reaction at the front, or the load carried by the front, will cause a counterclockwise moment with respect to A. So you're fixing it at the rear wheel. So this reaction will try to make this motorcycle rotate like this. So it's gonna be a counterclockwise moment, which is positive. So our front wheel, and that is 64 inches away from the rear wheel. And if you sum everything to zero, all moments sum to zero, you can find the front wheel reaction force that I calculated, 602 pounds. That is what I got for the front wheel reaction by taking moment in the other wheel. It's a kind of counterintuitive to think. Now you can take moments with respect to B. That will, not B. Actually, I said the MA is, this is the A. Generally, you use A and B instead of front and rear in most situations. So A is the rear wheel and the B is the front wheel. So you can take moment with respect to B. So this is with respect to the rear wheel. This is with respect to the front wheel. And the A and rear is the same thing. Is equal to 0. You sum everything to 0. Similar situation. However, in this case, all these different loads with respect to the front wheel, this 400 now will cause a counterclockwise movement. So all of this load will do a counterclockwise movement. So starting from the passenger, which is 57 inches away, so that will do a counterclockwise, which is positive. So 250 pound is 57 inch away from the front wheel, plus 350 pounds, that is 42 inches away from the front wheel, plus 450 chassis weight, that is 34 inches away from the front wheel, plus 400 pound engine weight, that is 25 inches away from the front wheel. Now if we solve for we're missing the rear wheel force, which will cause now clockwise. So the rear wheel reaction will push up the rear wheel, so it's going to do a clockwise with respect to the front wheel. So that's going to be a negative rear wheel reaction force times the 64 inch away from the front wheel. If you solve for this now, the rear wheel, I found that 848 pounds total. Now there is a way you can verify you have done all the calculation correctly or not. So here all the external load is 250, 350, 450. They're acting in all downward directions. So you can sum all this thing up, and I found 1450 pounds. And then if you sum these two, you calculated reaction forces. This 1450 pounds is carried by these two wheels, so there should be exactly 1450 pounds that I calculated. So to summarize, to calculate the reaction force after you draw the free body diagram in any situation, the first thing, you take moments at one of the reaction forces to cancel that particular reaction force, and then you get the reaction for the other one, and you take moment in the next reaction point, that will give you the other one. So you take moment twice to calculate the reaction forces at two different places if it's connected in two different points. And then you also need to verify adding all the external load should be the exact same as what you have calculated using your moment formula.